Well, to come to think of it, we have one more practice problem to take a look at, and this one's for the tin ion SN4 plus. Tin comes from the word stannum, was originally called stannum, which is where the SN comes from. That's why there's no T in the symbol for tin. It used to be called stannum. It starts with 50 protons, so it would have 50 electrons as well. Because when it begins, the number of protons should equal the number of electrons. The number of positive protons should equal the number of negative electrons. Well, if it's 4 positive, then it needs 4 more protons than electrons. So this one should only have 46 electrons when we are finished. Let's first do tin. 50 electrons for the tin atom. And here we go. There they are. There's the 50 electrons for the tin atom. How many valence electrons does the tin atom have? Remember, valence electrons are electrons in the outermost level. So there's a valence. My biggest number looks like it's a 5. Here's a 5 as well. So my valence is the 5th level. There's 2 electrons here. There's 2 electrons there. That means tin has 4 valence electrons. That should not surprise us, because if we look at the periodic table of ions, we will see right here is tin, number 50. And we go up to the top, and there's a Roman 4 above it. And it says that tin likes to become 2 plus, really likes to become 4 plus when it bonds chemically. So hopefully we'll have a chance to see why it really would prefer to become 4 plus if possible. Right here is tin before it's become charged. Now, when it becomes 4 plus, this is why this is an important example. Where did we say the positive ions lose their electrons first? The answer is the valence. So what is my outermost energy level, sublevel? What's my energy level, sublevel with the most energy? It is the 5p. So the first 2 it's going to lose are out of the 5p. So I'm going to ghost those electrons so that we know they were there, and now they're not. As mentioned, the first 2 electrons that tin will lose are out of the 5p. That is my highest energy level. So this would go down to 0. It lost those 2. Those 2 are ghosts. They are gone. Where do the next 2 go? This is why we're talking about this. Many students will want to pull the next 2 out of the 4D. They're like, that's what's next. Well, we realize that's what's next going right to left, but they go out of the valence first. So the next 2 that go out to make it 4 plus, these 2 made it 2 plus. This is tin 2 plus. To make it 4 plus, I need to remove the 2 electrons in the 5s, not the 4d. That is an inner level. So I'm going to ghost these 2. With those 4 gone, tin is now 4 plus. But why would this make tin chemically stable? We have to change that to a 0. Remember, stability, as we learned in some of the other ones we looked at, was an atom will chemically react so that it is left with a full S&P. Some of them, like arsenic, had to go out and get electrons to be left with a full P, S&P. Strontium was able to lose those 2 to be left with the full S&P. Tin had to lose 4, 2 out of the 5P, 2 out of the 5S, to be left now with the 4S full. By losing these, it's left with the 4s full, there's 2, and the 4p full, there's 6. 2 and 6 is 8. When tin lost those 4 electrons, it was left with a stable octet. These are not valence electrons now. It lost its valence electrons. So we would say tin has 0 valence electrons. Now let's move on and figure out how we can actually assign quantum numbers to any electron that we would like to. So for instance, what would be the quantum numbers for this electron right here? this electron, which I've now colored in green, I don't know if you can see that it's green. What are the quantum numbers of that electron? Quantum numbers, we require 4 numbers for the set. The first quantum number is going to be the energy level number. So that electron would start with, and I'll type these right up here, the first quantum number of that green electron would be a 2, because it is in the second level. It is a 2. The second quantum number tells you what sublevel it is in. When you are in the p sublevel, if you remember, your second number is a 1. When you're in the S, your second number is a 0. The P, your second number is a 1. If you're in the D, your second number is a 2. If you're in the F, your second number is a 3. So these numbers underneath the boxes, the N and the L, N's your first number, L's your second number, the abbreviation for your second number, 2 and 1. Third number is the orbital number. That is what is written above the box. The third number is your ML. Your ML, the abbreviation for your third number, your magnetic quantum number. That's above the box. In this case, it is a 1 as well. And your fourth quantum number is merely what spin you are. That arrow is going down, so that is a minus 1/2 spin. These are the 4 quantum numbers for that green electron right there. What would the quantum numbers be for this green electron right here? Once again, the first 2 quantum numbers are revealed underneath the box. This is my N right there. That is my N right there. So what is my N? My N is 4. So my first number in the quantum number set, my principal quantum numbers, is 4. My second number is the number that goes along with the electron's sublevel. Remember, when you're in the S, your second number is a 0. Now, why don't they just say 40? The answer is you can't put 2 numbers back to back like that because people won't know if it's a 40 or it's a 40. So when you're in the S, your second number is a 0. P, your second number is a 1. D, your second number was a 2. F, your second number was a 3. Where's my third number? Your third number puts you in the actual orbital. So what is the orbital number? That is above the box. The third number is abbreviated with the ML, magnetic quantum number. It is a 0 every time it is in an S, and this time the arrow is going up, so my spin would be designated as +1/2. You don't always have to type the plus in there. You can, you don't have to. The numbers for that green electron, 400 +1/2. What about the quantum numbers for this green arrow right here? What about the quantum numbers for that one? Once again, first quantum number is the principal quantum number. It's what energy level you're on. That is the first number underneath the box, a 4. The second quantum number is the number that puts you in the D. When you are in the D, your second number is a 2. Your third quantum number, then that's the L. So the N is 4, your L is 2. Your third quantum number, ML, magnetic quantum number, is which of the 5 orbitals you're in? Well, we are in the -1 orbital right here. We are in the -1 orbital. That is the number above the box. There are 5 d orbitals. The number above is telling you which one you're in. This one, the arrow's going up again, so we would call that a +1/2. This is how we do orbital notations. This is how we can assign quantum numbers for our orbital notations. I think you are now ready to begin the homework assignment 4-9. As always, if you have any questions with any of this, please do not hesitate to ask.